Hello and welcome everybody to today's Cisco ONE Fabric session. We'll be talking about how to connect VXLAN and ACI fabrics. My name is Larissa Overby. I'm a technical marketing engineer with the Data Center Networking Group. We do have a handful of panelists to help answer any questions that you guys may have. Please use Slido to ask any of those questions. We also have two surveys that we'd like you to fill out. One you can fill out leisurely during the session, and then we'll have a survey at the end asking about feedback and any suggestions for future sessions. So with that, let's get started. So we'll talk about the Cisco ONE Fabric experience. This is something that we've recently introduced that involves the introduction of the ACI border gateway. We'll go through in detail what that is, and then we'll talk about the control plane, the data plane as they function in the ACI fabric, as well as an XOS VXLAN fabric, and then interconnecting the two. We'll talk about VNI space namespace normalization and how that works when these are integrated. We'll go through the security policy enforcement phases, and then we'll end it with a demo. All right. So in today's complex network architectures, many times organizations have multiple types of networks, have multiple types of fabrics. These fabrics, they are needed to provide scalable, isolated network segments. There's often times when maybe two companies merge and they both have two different types of fabrics. There also may be times when migrating, oh, excuse me, sorry about that. Um, there may be times when a fabric needs to be migrated to another fabric type. There's times when companies may also need to integrate a data center fabric with a campus fabric and integrate those domains and carry that policy throughout. There's often times where the companies may need to include a remote leaf deployment or non-ACI VTEPs, or maybe even third-party VTEPs. So all of these different types of integrations with ACI or with migrations um, require separate VXLAN networks. And it could be challenging because this may require additional configuration and maintaining config in two different locations. And it's difficult to understand what configuration may be necessary to get those two fabrics to migrate or to communicate. There's a lot of underlying components that may need translation or mapping to be interoperable. So we recently introduced Cisco Nexus One that allows this integration. It allows the integration of ACI VXLAN and NXOS VXLAN EVPN fabrics, as well as other VXLAN fabrics, providing you with an open networking fabric experience. Now there's three important components in the Cisco Nexus One solution. The main component is the ACI border gateway that we've introduced that allows us to extend that VXLAN, IVXLAN fabric from ACI to non-ACI VXLAN domains and extend that VXLAN fabric from those VXLAN domains. The second component is the new group policy option in NXOS. This provides the security segmentation that many of you may know as ESGs and ACI, but this is done in an NXOS environment. The third component is Cisco Nexus Dashboard. This is the dashboard, the controller that currently manages and monitors NXOS VXLAN EVPN fabrics, and in the future will allow for this configuration and integration within Nexus Dashboard itself. So this integration will provide you with a single fabric experience. So let's go back and talk about um, how this is involved and how we're able to deliver this to you today. So over the years, we've had multiple data center fabric options. These options allow you to build smaller leaf spine topologies and interconnect with each other. In ACI, we first introduced multipod, which allowed you to connect two ACI VXLAN fabrics together with a single APIC controller. Then we introduced ACI multi-site, which allows you to interconnect two ACI fabrics with two different APIC controllers. Both of these options provide end-to-end policy throughout the fabrics, but it's limited on just ACI fabrics. Now, the physical connectivity of both of these can be done through an IPN, ISN, or back-to-back, depending on the environment or available connectivity. In multi-site, we still have that communication done through the spines. Now, we introduced VXLAN EVPN in multi-site, and that allows multiple leaf and spines in a VXLAN EVPN environment and allows those to be interconnected to each other. Now, this is done today with a border gateway. That border gateway is like the interface of the fabric, and it's the point of control, whether it's the V2, the L2 VLAN is extended, or VRF is extended to another site. This is supported with those two fabric types, but it's specific to VXLAN EVPN, and it only supports a single NDFC controller. Now, the latest thing that we've released prior to the ACI border gateway that we'll talk through is VXLAN EVPN multi-site, leveraging two different NDFC domains. So you could kind of see it as similar to ACI multi-site, where we have two different ACI controllers. And we're able to leverage these different multi-sites and have them communicate with each other, leveraging two different Nexus dashboard controllers. So let's talk a little bit about how the border gateway functions in an XOS environment and why we're going to need it to be able to integrate ACI and an XOS or other VXLAN domains. So in a non-multi-site fabric where we need to extend an XOS fabric between two physical sites, we can add additional leaves and sites and spines to the fabric. Now, depending on where these are located, there may be some cabling issues. They may be on different floors or different buildings. And also what we're doing is we're enlarging that VXLAN domain as we expand with additional leaves and spines. And that might introduce some scalability concerns. But if we move to a three-tier network, we can either add a super spine or a separate L3 network to build out that third tier. Now, this may resolve some of the cabling issues. However, that's still a single VXLAN domain. It's just a flat, larger VXLAN domain. So it may be difficult to scale out for the VTEPs, the broadcast, unicast, and multicast traffic. So moving to a multi-site network using the border gateway, we connect the border gateways to the spines, and then we connect the border gateways to a layer 3 network, as you see here. And now adding the border gateway for these two different sites, we're making it a multi-site network, but we're breaking up those VXLAN domains. So now we have two separate VXLAN domains, which allows us, provides us better scalability with our bum traffic and VTEPs. The border gateway will actually terminate the VXLAN tunnels, meaning the VXLAN will be de-encapsulated and then re-encapsulated again sent to the other site when it's going through the border gateway. So this provides more scale. It breaks up those VXLAN domains, And it also makes it easy to extend and then stitch multiple VXLAN tunnels together. This is very similar to what is being done with ACI multi-site between the spines, just the spines today. So let's talk about now interconnecting these non-ACI fabrics with ACI. Now, the traditional approach of interconnecting these data center fabric types calls for the creation of dedicated layer 2 and layer 3 connections between the different domains to facilitate that extension of the layer 2 and layer 3 connectivity. But in doing so, this can create loops within the L2 environment. This would then require spanning tree, and if the optimal path is blocked, then the traffic would need to traverse the less optimal path, right? Something that we've been uh, trying to avoid for years. Now for layer 3, where we would then need to create multiple peers, and we would need to create multiple peers for what we would need to create a peer for each VRF that we're extending. And this may end up being harder to maintain and might not be able to scale out. So with the introduction of the ACI border gateway, with that border gateway functionality, we can address these issues. For the layer 2, we have the general IP connectivity between the fabrics, which removes the need for that L2 DCI extension. We would then extend that VXLAN overlay. In this case, we still have a single VXLAN overlay between the 3 pods in this multi-pod. But then for layer 3 reachability, we can leverage just a single BGP EVPN session that carries all the VRFs that you want to exchange in that environment. So you can see it reduces the configuration law as well as improves the scalability. So we have this new ACI border gateway that provides that border gateway functionality to ACI and between ACI and other VXLAN domains. This was introduced in 6.1, and we have multiple functionality that support that entire feature being released with our ACI 6.1 releases. That's through ACI 6.1.4 most likely. So we'll talk about the detailed functionality in the next couple slides. But first, if you guys can give us an idea of what fabric solutions you currently have today. You can easily scan that QR code, or you can join at slido.com leveraging the 1946-847 number and the passcode ORDC83. And feel free to fill that out throughout the session. We have one more question for you, and then we'll have a survey at the end, as I mentioned before. So let's go into those details. So in 6.1.1, we introduced multi-pod support. So in this case, we're able to have ACI multi-pod. Each pod will need to have its own set of ACI border gateways. And then this is with the multi-site VXLAN EVPN. So you'll see we have a single APIC domain on the left-hand side with those 2 pods. The extension of the connectivity is between the spines through the IPN or ISN. This will continue to work just as it is without needing the border gateway. So that functionality will still be done. But when we're communicating and connecting with the VXLAN, the NXOS VXLAN, we'll then end up using that border gateway, and we'll be able to extend that VNI over the VNIs over to the other VXLAN fabric. So we'll leverage that ACI border gateway for each pod. As I mentioned, they'll have their own set, and as well as the border gateways on the NXOS VXLAN EVPN side, which each site also has um, its own set. For each of the bridge domains that are extended across, a specific ACI border gateway will end up being elected as the designated forwarder. And the ACI border gateways in this case are also dedicated layer 3 nodes. So at this time, they'll only be used for layer 3 connectivity. We can't connect endpoints or anything else to that. So in 6.1.4, we'll be able to not just have a single ACI fabric, but we'll be able to have two independent ACI fabrics that will both use their own set of border gateways. So in this case, between those two independent ACI fabrics, we won't be stretching the layer 2 and the layer 3. They communicate if needed through the VRF Lite or the L3 out or VLAN handoffs. But then when we extend those independent ACI fabric VNIs over to NXOS VXLAN, we'll be able to do that through that border gateway. When we do extend it, in this case, the VNIs for each ACI site do need to be independent. So we can't have the same. We can map that to the same, but we cannot have the same VNI for each ACI site. And that's mainly due to split horizon, which we leverage for our border gateways to help prevent loops. So the border gateways won't advertise routes learned from the interface that it learned initially learned the route on. So let's go through the IP addressing for the ACI border gateways. And there's quite a few of them. So bear with me here. So for the control plane, we leverage a few different IP addresses. We have the EVPN router IDs, and those are the loopbacks. They're used to peer the BGP EVPN sessions. Each border gateway will require one of these. Now we have the PIP, which is another loopback interface. And that's used to encapsulate the traffic sent to the external site. These do exist in the routing table. They're used as the source IP for all traffic sent toward the remote VXLAN EVPN domain. They're used as the next hop for type 5 prefixes that are received from the VXLAN EVPN domain and then injected into the ACI fabric using IPVN4 or IPNv6, depending on. And these are unique per border gateway. Now we have the multi-site external VIP, and these are shared between the border gateways. It is called a virtual IP, and they're used for the Anycast IP as the next hop for type 2 and type 5 EVPN routes advertised to the remote VXLAN EVPN fabrics. They're also used as the destination IP or the Anycast IP or the next hop for the L2, L3 communications that are initiated from the VXLAN EVPN domain toward endpoints or external networks that are reachable via ACI. These are unique value per pod as well. Then we have the external VIP, which is only on the ACI side. This is used to advertise to the other fabrics for the local endpoints and external prefixes. It's used to receive traffic destined to a local endpoint. and it is the um, destination endpoint that will be in the outer VXLAN header for endpoint sourcing from the other fabric. Then we have the internal VIP. Now the ACI internal VIP, it's not advertised outside the ACI fabric. This is used within the ACI fabric for internal COOP processes. It's used as source IP for all traffic received from the VXLAN AVPN domain. It's then used to re-encapsulate and be sent into the ACI fabric. This is also a destination IP for all the traffic destined to those remote endpoints. It's a common value assigned to all the ACI border gateways that are part of that same fabric. All right, so to exchange that underlay reachability, the L3 out in the inference tenant, and that's where actually we'll create this VXLAN L3 out, which I'll show you in the demo. That's used along with the multiple prefixes previously shared, just as this is done with ACI multi-site or multi-pod today. That underlay creation is done between the ACI border gateway and the ISN. We're only supporting eBGP today. The interface that connects to that ISN, it does need to be a downlink. So different than in a multi-site or multi-pod where they're fabric port uplinks, but that does need to be changed to a downlink. Right. And once that underlay is created, the IP addresses are then advertised to the ISN network. So you'll see these are all advertised in the global routing table. And then once that underlay reachability is done and established, the full mesh MP BGP EVPN is then created. So they can now advertise all type 2 endpoint IPs as well as type 5 external prefixes. So let's go into more details on this and talk about the control plane. So let's look at how the endpoint information is exchanged. We'll start on the ACI fabric. So if you guys are familiar with how the endpoint information is exchanged today in the ACI fabric, it's the same. Same with in XOS. The functionality within the two fabrics are the same. The only changes is how that information is leveraging the border gateways to communicate, and then leveraging the spines to communicate outside of their fabric as well as inside their fabric. So we've been using COOP as our protocol in ACI to discover endpoints, and it'll continue to be used. COOP reports the endpoint information to the spines from the leafs, and they'll report this information to the spines. And the spines keep this information in their own COOP database. It'll contain the VTEP information as well as the IP address. The spines will then replicate this information to the endpoints. They'll replicate this information to the other spines. And then sorry about that. And then, so that information is replicated to the other spines. The leafs don't have to send any of this information, so it helps a little bit with scale. Let's go to the next slide. So then once the spines have that information, EVPN is used to exchange that information with the ACI border gateways. And that connection is MP BGP EVPN. They will advertise their local endpoint information, and the information now would have the endpoint address and the proxy TEP. The spines proxy TEP is used to tie the endpoint IP in this database. For external prefixes or type 5, they're communicated a little differently. The external prefixes uses MP, BGP, VPN v4, or v6, depending on the IP type of IP traffic. The spines are used as the route reflectors. The external prefix information uses the spine's route reflector to propagate to all the leaf switches. We then extend that MP BGP VPN to the border gateways. So now the spines have both the endpoint and external prefixes initially learned from the leafs and the border gateways will then get this information and have the border leaf TEP as well as the proxy TEP IP depending on endpoint or L3 out external connect prefix traffic. So then that's shared with the border gateway in the NXOS side. And they're all advertised using that ACI multi-site external VIP. We did just start supporting route maps in 6.1.2, so you can leverage those to limit certain endpoint IPs or external routes from being advertised. So all that gets advertised to the NXOS BGW. The NXOS BGW then receives that information, puts it in the information to their database, and just as NXOS communicates type 2 and type 5 traffic or information today, that will get communicated the same. So that all gets advertised through EVPN, leveraging that event. All right, so the reverse, it's done the exact same way in both of the fabrics, using EVPN in NX and COOP in ACI fabric, and that gets communicated to the other border gateway. So we'll talk about the data plane overview. This one's a bit easier. So now we have the control plane information that the ACI fabric, from the ACI fabric to the NXOS VXLAN EVPN fabric and vice versa. We can build out that data plane with the VXLAN tunnel encapsulation. So the data plane stitches 3 different VXLAN tunnels. So you may remember at the beginning I had said we had multiple VXLAN domains. We have that separation here, and this is where you'll see that being done. So we will do the encapsulation and the encapsulation within each of the fabrics. They'll get de-encapsulated at the border gateway. There'll be a tunnel created between the leaf and the border gateway. For the ACI fabric, the destination will be the ACI MS and internal VIP here, or the physical IPs of the border gateway, since we leverage ECMP. For NXOS, the destination will always be the MS internal VIP. All right, and then we have the last VXLAN, and that's done through that end-to-end, the tunnel stitching to build out that end-to-end connectivity for those 2 different VXLAN domains. All right, so we'll touch on the VNI namespace. So today, when we build out a VRF and a network in NXOS, we're able to define what that is. In ACI, we're not able to define the VNI namespace. So these are used for the BD, the network, the VRF, and they're always associated to an L2 VNI or an L3 VNI. When it's configured on ACI, we're not able to customize it, but there is the or the bridge domain, and there's a L2 VNI number that's provided. Um, so what that means is we have to do that mapping manually. So whatever that VNI, which I'll show in the demo, whatever that VNI is on ACI, we'll then have to assign that to one that we create to a network and a VRF that we create in XOS. So technically, this means that we're only supporting greenfield at this time. So in 6.1.4, we'll bring in the translation functionality into the ACI border gateway. So the VNIs will have a local value that APIC assigns, but then we'll be able to um, automatically translate that to um, a global VNI. All right, so let's talk about policy now. So in 6.1.1, when we initially introduced this, we did not allow any contracts. And you'll see in the demo, I do have 6.1.2, but I don't have the VRF enforcement on. So if you do implement this in 6.1.1, you you will need to turn off the enforcement on the VRF. And this is also assuming that we have no GPO configured on the NXOS side. So we have no enforcement in 6.1.1. In 6.1.2, we did introduce policy enforcement, but this is only done at the ACI border gateway level, and it does require leveraging ESGs. So you would have to change your EPGs to migrate your EPGs to ESGs and and leverage those ESGs. Um, this provides that separation of connectivity and the policy. It's the ESGs are more closely tied to how the group-based policy option has been implemented. It's a bit more scalable, a scalable way to define the policies in ACI. So you'll need to migrate those EPGs to ESGs. Um, and then we can now configure enforcement in the VRF, but it's still going to be done on the ACI border gateway side. So the traffic that comes from the NXOS fabric into the ACI border gateway, it'll be propagated, um, and those endpoints and those external prefixes will be learned, but then it'll be classified at the ACI border gateway. So the contract is actually implemented on the border gateway, on the ACI side. All right, so in 6.1.4, we'll be able to share ACI ESGs as well as NXOS GPO's security groups. So instead of needing to configure ACI to do the classification of the endpoints and external IP prefixes, we can obtain the classification from through the EVPN routes, and then we'll be able to do this on both sides. We'll be able to have the enforcement and share that information. So quick recap and summary. We've got three main pillars of Cisco Nexus One, and that's the border gateway functionality coming into ACI, which really opens up this whole possibility and allows us to leverage those, be able to do those different use cases, leveraging the ACI border gateway. So if we have cases of migration, we have from ACI, from VXLAN to ACI, if we need to interconnect ACI and VXLAN fabrics, we're able to do that now with the ACI border gateway. We're able to maintain segmentation and policy throughout, leveraging group-based policy a group policy option which came out on NXOS recently, and eventually we will be able to have these all centrally managed on Nexus dashboard. So before I go to a demo, actually while I go to a demo, if you guys could think about your own environments and how you would be able to leverage the ACI border gateway. Is there something that you guys have? Maybe you guys have a migration, maybe there's a new acquisition. If you could take a quick second to answer that question, and I'll move on to the demo. All right, we just re-log in to everything. All right. So you can see here we have an ACI fabric, which has a single pod, and we have an XOS fabric. We are leveraging NDFC, and we have a single site here. We have the ACI border gateways here, and we're actually, we've got the spine border gateway role in our NXOS fabric. And that is something that you can do. You don't need to have a dedicated border gateway. Um, you do need to on the ACI side, but for NXOS, you don't need to. And we're connected through a single ISN now. So we have two endpoints in this fabric. They're both in the same IP range because we have stretched that L3 domain. We've got 10.16.24.10 in the ACI fabric and 10.16.24.20 in the NXOS fabric. So let's first go to APIC. What I'll first go to is how you would, the first steps that you would do. So you would connect your border gateway to your ISN and your ACI border gateway to your ISN and to your leaves, and you'll register it. And once that gets registered, you'll see that here. Once that gets registered, then it will then become part of that fabric. We have two pods in this case. We just haven't connected them all. And the role will be border gateway. So that'll go through its process. I do need to change the uplink to a downlink that requires a reboot, but we're going to go ahead and go through the rest of the demo leveraging the border gateway that we actually have connected already in pod 1. So we'll do this in the infra tenant. It's going to be a VXLAN L3 out. So we have the ACI border gateway here. We have the external data plane IP. This is what we have to manually assign it. This is the internal Anycast IP address, and you can see it's attached to the MTV VXLAN fabric. That MTV VXLAN fabric is those spine border gateways. So you'll see 10.502 here, and in our MTV fabric, we have our spine 1, our interfaces, and you'll see the loopback is here, 10.5 02. So that's what we have. We've added that remote EVPN peer here. Um, there is a workflow for going through this, which I won't go through. As well as the the NXOS fabric, um, and it will then create the peering for the underlay and the overlay. So let's look at the devices. Just log into all of these. Oops. All right, so let's look at we have here. So this is the ACI border gateway. It's connected to that ISN, and you'll see, I should have just done it here. You can see we have the MTV Spine 1 connected to the ISN and the ACI border gateway also connected there. And let me do one thing. All right, so, okay, so let's go through and just do some verification. So you'll see multiple interfaces on the border gateway. This 10.16.0.61 um, is the pairing with the ISN. So you'll see this is on an interface I had to create as a downlink, and I paired it with the ISN here, 10.16.0.2. You'll see loopback 0 here, which is automatically assigned. And then you'll see here, this is actually the peering um, with the Mountain View spine here, which is the VXLAN. Actually, I'm sorry. Here, you'll see 10.16.0.74, the ISN, which is connecting the point-to-point link for the NXOS fabric here. So then if we look at the routes, which there'll be a lot, but we'll look at some here. Okay, so you see the 10.16.0.53, you see the route map here. And see all those see those there. And then let's go to the um, NXOS side. Let's look at that VRF. So 1016 24 is our uh, that's our L3 network that's been extended between the two. And let's look at endpoint here. So you can see 1016 24 20 here. I should log into the Leaf 3 on in XOS side, but let's look at from the GUI standpoint. So I had mentioned that, actually, let me go back. So that VXLAN L3 out is configured in the infra. But when we do our extension for the VRF and the BD, we do it within the tenant. So you'll see that endpoint, the ACI side endpoint 24, actually uh, 24 there. And let's go within here to the VRF. So we have this, we created a new VRF that automatically got assigned this segment ID. So what we had done was we created the VRF on the NXOS side, and we assigned that VRF ID, because I mentioned before that we have to manually assign that. So that's what you see there. And then let's go to our bridge domains. You'll see the bridge domain here. It's been attached to the MS VRF, and that segment ID of 140 you'll see here. So we've assigned that as well. We have leveraged NDFC for doing a lot of this configuration, but you can manually do the configuration with NXOS. You'll see here, which you'll see these in the slides as well as the documentation on configuring this in ACI. We do need to set this to flood, and also let me go back to my VRF, and even though we can do enforced, I haven't turned that on yet. But this VRF is currently in unenforced mode. And let me just go to, all right, so now let's go to, we have the .10 and the .20 endpoints. So let's look at their connectivity here. Let's bring this around. So you'll see this is 2410, which is the ACI endpoint. Here we have 2420, and sometimes pinging takes a while, but let's so we can ping the gateway. Sure, we can ping. All right, and then let's ping 20, which is going to be ACI. So this is our NXOS host, and we're able to ping and communicate between both of the endpoints in the NXOS fabric and the ACI fabric. As I mentioned, we don't have enforcement on, so there's no contracts, there's no enforcement on the VRFs. So by default, these can access each other. But you've seen that it's fairly simple to do. I do have in the slides um, the specific steps on how to do this. There's also a ton of reference information, and as will as we end up doing this, expanding on this with our various releases, you'll be able to take advantage of this. We do have, like I said, the last of it in 6.1.4. Actually, not the last of it, because we will still have a little bit more when we bring out the functionality into Nexus Dashboard. And so hopefully you guys found this session useful. If there's any questions that are unanswered, I could answer those live. And we also have a survey for the session. If you'd like to give us some feedback, let us know how you like the session. Let us know how you can take advantage of this feature. And thank you all for attending.
Thanks, Larissa. There was one question about Nexus Dashboard from Kevin, asking if it included configs for the infratenant border gateway and the ISN routing. So would you want to talk a little bit more about what some of the plans are for Nexus Dashboard, especially as we come into the 4.1 and 4.2 releases this summer?
Sure. Let me. I've got have a slide here. Maybe I don't. Yeah, so we are going to be putting this into Nexus Dashboard. We're looking at 4.2, where we're actually able, I don't really want to end on that slide, where we're actually able to do the configuration for both the NXOS side as well as the ISN and IPN. Now, in our setup, we actually had done that configuration with as a manual workflow because it's not yet defined in Nexus Dashboard. But as you probably know, Nexus Dashboard supports a lot of different types of devices, whether it's NXOS or iOS XE devices. And so if you know the configuration that can be applied, then that's where you would, then you can do that with NDFC today, which is what we did. And we're working on a white paper that will, a deployment guide that will guide you through that should you not want to use Nexus Dashboard. But we are looking at probably 4.2 for putting that functionality in Nexus Dashboard.
All right, excellent. I think that's it. Thank you.
Great. Well, thank you, everyone. Please take a little bit of time and fill out that survey. If you guys have any sessions that you'd like us to cover for you, let us know. We've got a lot of experts in the house. Thank you very much.
Take care. Thank you.